Okay, so we're going to have a look at question 9.3 from the study guide. Okay, so we've been told, suppose A is a bounded subset of the real numbers, and let B be the set defined by B such that B is equal to 2 times by 3 plus, B is equal to 2 times by A plus 3, where A A belongs to set A. Okay, and we need to show that the supremum of B is equal to the supremum of A times by 2 plus 3. Okay, so we've been told that A is a bounded subset of R. Okay, so by the continuum property, we know that A must have a supremum. Okay, so we can denote that here by epsilon. We can say epsilon A, that's equal to the supremum of A. Okay, and we know every single element in A, which is denoted by little a, is smaller than or equal to the supremum of A. Okay, so now straight away we know what A is. Okay, A is just equal to B minus 3 over 2. Okay, if you take an element from B and you minus 3 from it and you divide it by 2, you'll get the corresponding element from A. Okay, and that is always going to be smaller than or equal to the supremum of A. Okay, so we've so now we can simply just rearrange, and we can show that B is always going to be smaller than or equal to twice the supremum of A plus 3. Okay, so what we've done now is we have shown that the set B is bounded above. Okay, so this small b could be any element from set B, and we've shown that any element in set B is always going to be smaller than or equal to twice the supremum of A plus 3. Okay, so we've shown that B is bounded above, and hence we can say that the supremum of B exists, and we'll just denote it here. We can just say epsilon B is equal to the supremum of B. Okay, and now we can simply say that the supremum of B is going to be smaller than or equal to twice the supremum of A plus 3. Okay, because we know that every element in B is going to be smaller than or equal to this. Hence, the supremum will always be smaller than or equal to this as well. Okay, so we've now shown that the supremum of B is going to be smaller than or equal to twice the supremum of A plus 3. In order to show that they're equal, not less than or equal to, we have to essentially, so now what we need to show is this. We need to show the supremum of B is greater than or equal to twice the supremum of A plus 3. If we can show these two things, it means that they must be equal. Okay, the only way for these sigmas to satisfy both these inequalities is if they are equal, like in the case up here. Okay, so we're going to do the same thing again, just the other way around essentially. Okay, so what we're going to say is that A is equal to A such that A is equal to B minus 3 over 2, where B belongs to B. Okay, we're essentially just defining the set A relative to B, if you like. Okay, so we know now that set B is bounded above, so we know every element in set B is going to be smaller than or equal to the supremum of B. Okay, and now we can just do the same thing again. We can rearrange, and we can get B equals to 2A plus 3, and that's going to be smaller than or equal to the supremum of B. And now we can rearrange for A here. Okay, so we can say that A is always going to be smaller than or equal to Oh no, in fact we don't. We don't have to do that. Okay, so what I'm going to do now is I'm just going to write this inequality the other way around. Okay. Oh, in fact I am going to do that. No, I am going to, no, yeah, so I'm just going to continue to do what I was doing originally, and I'm going to rearrange for A. Okay, so I get A is going to be smaller than or equal to the supremum of B minus 3 over 2. Okay, so now I've shown that the set A is bounded above by this. Okay, the supremum of B minus 3 over 2 is the smallest term, which is larger than or equal to any of the terms in A. Hence, I can say the supremum of A is always going to be less than or equal to the supremum of B minus 3 over 2. Yeah. Now I can just do a bit of rearranging. I'll come up here, and I can say that 2 times the supremum of A is smaller than or equal to the supremum of B minus 3. Okay. And I can just add 3 on both sides now. 2 times the supremum of A, add 3 is going to be smaller than or equal to the supremum of B. Okay. So I have now shown what I needed to show. Okay, I've shown that supremum of B is greater than, so I needed to show this part. And I have. I've shown that supremum of B is greater than or equal to twice the supremum of A plus 3. I can now say, we can say hence. If I had enough space, I could probably just write a little statement here. Hence, I showed that this is true, and I showed that this is true. So this means that the supremum of B is equal to 2 times the supremum of A plus 3. And that is what was required from us in the question. Okay, so I hope this video helps, and thanks for watching.